Okay,
All yours.
thank you.
Yeah, good.
Okay, good afternoon everyone. Welcome to this session on being a productive developer with React. So today I'm just doing a breakout session, 1 hour. On Wednesday I'm doing a full day workshop on this, so you can come in, bring your own laptop, and we actually get to do this hands-on, and we can go into much more detail, much more depth. But now we're going to do the regular breakout session. So who am I? My name is Maurice Beijer. I'm from the Netherlands. Unfortunately, I don't speak Hebrew, so if you ask questions, that's perfectly fine, just shout out. But do so in English, otherwise I'm not going to be able to understand you. Like me doing the workshop in Hebrew, that's not going to fly unless I manage to learn Hebrew in 1 day, which I don't think is quite possible. Anyway, I'm a Microsoft MVP. I'm also a trainer developer. I kind of train people in the stuff I develop myself, and I develop with the stuff I train people in. So kind of a win-win situation. And right now I'm developing course material on both React and Angular, kind of an overview. So if you're looking for me presenting React and bashing Angular, from Angular is bad, you should never use that, too bad. I kind of like both. So what's React? Well, React is a JavaScript library for building user interfaces, which is the quote from the Facebook website, because Facebook is the company that makes React, which is kind of vague, like what does this even mean? I could say the same about jQuery or Angular or pretty much anything out there. So where does React come from? That might help a bit more in explaining what React is. Well, React comes from Facebook. Basically, Facebook had a problem creating their main website, the big Facebook website, because there's lots and lots of stuff there, lots of different components doing different things, and that all has to work together. So some people, notably Jordan Walkie at Facebook, starts creating a library to do user interfaces like that. Complex user interfaces with lots of interaction between different parts, but still optimized to only render the minimum of amount needed. So they did that and they open sourced it, and now it's being used in lots and lots of companies. So the main Facebook website, Instagram, which is owned by Facebook, Airbnb, what else? Netflix. In the hands-on lab, we're actually going to build a clone of Netflix, which kind of is appropriate, being in a cinema complex. Netflix competing with the cinema, well, we'll compete with Netflix. But many, many other companies use it. It's got a BSD license, so it's quite permissive. You can use it in closed source software and create all sorts of business applications with it. So I always get the question, React, Angular, what should I choose? And that's kind of hard to answer because it really depends. But one important thing about Angular is it's very opinionated. It's got a very strict, it's got a detailed style guide on how to do things. They're very opinionated about how to do things, from use the Angular CLI, use TypeScripts and all of that. And you can do things different ways, but they really like you to do things the way they do. React, on the other hand, is very much relaxed about that. They say, okay, we'll let you build components, but how you're actually going to assemble those, whether you use Webpack, whether you use TypeScript or ES 2015 with Babel, that's really up to you. And as a result, you see on the Angular side that there is basically one way to create Angular applications, the Angular CLI. Or you could create them by hand, but if you're using tooling, because you want to be productive, there is the Angular CLI. But with React, no, there are lots and lots of starter projects. Like, this is a screenshot from a website about finding the right starter project for your React application. And they've got currently 107 different starter projects on there. That's public starter projects which are relatively well used, hosted on GitHub. There are many more private ones, just people who created their own little stuff and never made it to the public world, never open sourced it, or for some reason didn't appear on this list. But the top one, the one right there, that's the Facebook React app. That's also quite minimalistic. You can see that there are only a few tags there. It doesn't add a whole lot. It just adds the minimum, and it kind of says, well, we'll do this basic stuff. We'll create a new React application for you. And then you go and decide how to do it. It's not very opinionated. Lots of the others are slightly more opinion. They say, well, you'll use Webpack, TypeScript, Redux or MobX or one of those things. Facebook kind of leave it very open. But they did build Create React app. In fact, they did build it sort of late. Most of the other starter projects were out there and been used for quite some time before Facebook actually built the Create React app utility itself. But it is kind of good. It's, well, sort of the official starter project. And if you create a new application with it, you'll get all of this beautiful application. Now I've already created one, just in the interest in time, and it's running here, and this is really all you get. A beautiful spinning React logo, welcome to React, and a little helper text. You can go and edit app.js and save it, and this will update. In order to start it, you can just run npm start, which I've done in this console window. Normally it would open on port 3000, but I'm already using that for something else, so it switched to 3001. And I've got the application open here in Visual Studio Code. It's kind of like use whatever editor you want. I personally like Visual Studio Code, but lots of people use Sublime or Atom or one of the other things. And I can go and make changes to it, like add some dots, for instance. Now I've set Visual Studio Code to auto-save when it leaves focus, so if I Alt-tab back to the browser and don't do anything else, it will automatically update. It uses push notifications on the server parts of Create Web App, determines that there is a change, it recompiles the code on the fly, notifies the browser that there's been a change, and the browser will automatically refresh. So that's kind of nice. I can just sort of quickly make changes here, remove those dots again, back to one space, switch back, and well, less than a second later my UI is updated. But other than that, Create React app doesn't really give you a lot. It's set up the project, it's set up transpilation or compilation using Babel and Webpack. It's created a little server, it's created a single component, and that's about it. So as starter projects go, it really is quite minimalistic. So one thing people kind of have to get used to when they start with React is JSX. Normally, if we're on the web, we write JavaScript, maybe ECMAScript 5, maybe ECMAScript 2015, or maybe you're writing TypeScript, which is still a superset of JavaScript. In the case of JSX, that's not so much the case. They're combining JavaScript with markup. And if you've done web development for any time, you might have started off with creating HTML pages and embedding your JavaScript in there. And then we were told that was bad. You should not embed your JavaScript in your markup. So we started creating JavaScript files and HTML files and linking to the JavaScript file from the HTML file using a script tag. And that was good. And now the React team comes and says, well, here's JSX, and now we're going to combine everything again. Except we're going to combine things in a very different way. Here's a JSX example. And you can see here there is a render function, so there is code. There is a const movies is, so basically the ECMAScript 2015 constant. Could use a var there. And there is a return statement, all pretty much standard JavaScript. But then if you start looking here, you're going to see diff statements, angle brackets, diff, class name, something. So that kind of looks like markup. And it is markup. This will be rendered by the browser. Except now we've kind of combined this. And the JSX syntax and the React plugin to Babel actually transpiles this into, well, something the browser can understand, because this is something the browser would not be able to understand. So what does that look like? Well, let's create a very simple component. If I can switch to the other window. I've got an empty file here, demo.jx, and I've got some snippets installed in Visual Studio Code, so I can quickly create a component. So there is a React component, and give that some demo. And you can kind of see the basic component. So the render returns a div, and I can put some text in here. Hello, world. Now, what happens during the transpilation phase? This actually gets turned into something else. So this would actually be turned into return react.createElement of a div, and the second parameter is going to be null, because we're not using that here, and the third would be hello world. World, like this, with an R. So that's what's happening underneath the hood, which kind of explains one funny thing which always catches people. If you look in here, you see in the first line an import of React, but React was never used anywhere else in the code. Still, that's required. If you're not importing React itself into this component, we would get a runtime error. Let me show you what happens if I actually embed this. So we'll import it here. Import demo from demo. And we can include it here. Now, it should show up in here. So we see the string hello world. Suppose I go back to demo and say, well, we're not using React here, so we don't need to import it. I switch back and we get this beautiful error message. React must be in scope with using JSX. So that's because of this transpilation stuff, where behind the scenes these markup elements, which appear as markup, are turned into React create element calls. So it should be fine again. There it is. So if you start building React applications, you really have to start thinking in components. Your whole UI is built up of components. So components are the basic building blocks. And a very simple application could look something like this. So at the top here we've got our root application. And in this case it's going to render either a login, a main page, or a playing movie component. This is the thing we're going to build on Wednesday during the workshop. And this main page consists of a number of other components, a header, a billboard, and a list of genres. And that list of genres contains of a list of other elements, and slightly out of screen you can see a list of movies there, which is kind of how the actual Netflix screen is built up. If you go and inspect that, let's see if my internet's good enough to actually show Netflix. If I can type, what's happening? My keyboard stops. Well, I guess we're not going to show it, but if you go to the Netflix site and you inspect it, you can actually see all those components there. So a little more about components. There are different ways you can create them. First of all, they're typically done using ECMAScript 2015 JSX. So we're using import statements, the ECMAScript 2015 imports, to grab other stuff. So we're importing React and component from the React library itself, and in this case we're also importing something else. So the import path from /config. The / is a relative path, so that's local file. The React on line 1 is not a relative path, so it looks it up in the npm modules. Then we define the component and we want to use it, so somewhere else we're doing an export. Could be named export, but in general you've got one component in a file, so default exports are used. Then by far the most common way of defining components is creating an ECMAScript 2015 class and extending from the ECMAScript or the React component class. There are different ways. You can use react.createClass, which was the original way of doing it. It's not deprecated yet, but they're talking about deprecating it, so I would avoid using that unless you've got a very good reason to. The other reason is to use what they call functional components, which are simpler and have less capabilities. And right now they don't really offer a lot of benefits, but they have planned enhancements to the React framework which will make functional components faster. But right now they're not really faster yet. Now every component needs at least a render function. That's the one must-have for a component, and that render function returns some markup. So in this case it returns a div with a class name row, etc. That class name is slightly different than what you might expect. If you're looking at normal markup, you would say div class of row. But because class is the reserved word in ECMAScript, Facebook actually said, well, we're not going to use class, we're going to change it, so we'll use class name. For the most properties you'll use, you can use the standard names, but there are two which are commonly used where you can't do that. So class name is by far the most common. The other is the for attribute you might use with a label and an associated input control. So you use the for of, the HTML for it is. So another thing is you want to display something. Well, in this case, we want to display a movie title. So you use the single curly braces to include some kind of expression. That can be simple like this. So movie title is just a string. So all this would do is just render the string of whatever movie this is. But that can also be a more complex expression. You might have an array there and you map array elements to different components, or something else. You could embed any code in there. In general, my advice is keep those expressions simple. Something like this, fine. An array.map, fine. But starting to embed code again here, no. Put that above the return statement. Keep that outside of your markup block. So React is kind of agnostic to what you're going to do with it. It doesn't say, well, you're going to render it to the browser in the DOM. It really could be anything. There is another project related to React which is called React Native. And you can use that to build iOS or Android applications using React. Of course, you're not going to render a div or a span there. You'll render different elements. But the whole React syntax and everything on how it works stays exactly the same. So the actual rendering to the DOM is done by a different package, which is called React DOM. And that's the thing you use to render a React application in the browser. So it's relatively simple. You typically use this only once in your application. You import React DOM, and then you typically use this render method here, where you say, well, render some kind of element, the app, in this case, and the second parameter is a DOM element where you want to render it into. So typically you've got some kind of DOM element. In this case it has an ID app. You reference that document.get element by ID or whatever selector you want to use, and you pass that into the second function of React DOM.render. Our Create React app also did that. It did it slightly different. In this case, you can see over here, it's actually used JSX syntax on line 7 for the app element instead of React.createElement, but it turns out to do exactly the same. This would get transpiled to what I had on the slides. So React DOM is kind of nice when we're in the browser. It makes sure that our React application gets rendered. But we're not always in the browser. Some cases you might want to do server-side rendering. And why do you want to do server-side rendering? Well, there are a couple of good reasons. First is search engine optimization. If a search engine, one of those robots, goes to your sites and indexes it, some of them execute JavaScript, but some of them don't. Googlebot is quite good. It will execute JavaScript, at least to some extent, and for the most part it will index a client-side React application. But the Bing bot or Baidu or one of those other search engines, they're not going to do that. They're just going to grab whatever HTML is returned and they're going to look at it and say, well, that's not a lot. Let's see what our Create React app actually returned. Where's my index.html? Sorry, not in node modules, in public. So that's it. There is a whole lot of comments, but if you look at the actual markup, there's nothing there. So nothing really to index. So for a search engine, wouldn't be very interesting. Now we can say, well, if we, instead of rendering the application at the client, we start rendering it on the server and sending the already rendered application to the client, now any search engine would see the actual markup and be able to understand it. But it's not just for search engines. It's also for performance, or at least perceived performance. If a user goes to a React site and all he downloads is that tiny bit of HTML and then some JavaScript and then that has to convert everything and then has to render, it takes time for everything to render. And on a desktop machine, that's going to be plenty fast. But on a laptop or a mobile device, on a 3G connection, there's going to be a noticeable delay. Now again, if you server-side render first and then you send the already pre-rendered HTML to the client, they're going to see a decent looking UI much faster. React is still going to render it client-side again in that case, but it's basically going to see, well, we've got a bunch of markup from the server, we rendered our application on the client, it produces the same markup, so it's not actually going to do something. The React DOM diffing algorithm is really good and it detects that there are no changes, or at least hopefully no changes, or if there are any, there are very few. So it will be very fast. So while it's not required, it is really beneficial. So components, like I mentioned, are really the mainstay of React application. You create components. But components like the real simple ones, which I just created, like, where is it? Over here. That's only so interesting. It will render hello world every time it's called. So there's really nothing dynamic about it. It's never going to render anything else. So what's the point of rendering anything client-side then? Well, that's where props comes in. Props are basically the inputs for components. If you think of components as functions, then the props are the function parameters. And if you think about functional programming, well, if you've sent in the same parameters to a function, you're going to get the same output from it. In this case, if with a React component you send in the same props, you should get the same output again. So for an example on how that would work, here I've got two components, a parent component and a child component. So first we'll take a look at the parent component. And here inside of the render, we're actually going to display a list of movies. So we see there is a wrapping div class named movie list, and inside of that we see there is a movies, wherever that came from. And we're going to call the map function and basically transform an array of movie objects into an array of movie components, passing in that movie as the component. Now you'll see on line 8 there is actually a second property there, the key. Anytime in React you do repeating items, then you have to pass in a key, which the React DOM diffing algorithm uses to detect if there were any changes. You have to do that every time you've got a repeating value. If not, you'll actually get warnings inside your console window from React saying, well, you should specify a key here. It's quite good in giving you help about these missing things. It should always be an immutable thing. So don't use the index from an array if you're going to add or delete items for it. Typically use some kind of, in this case, a movie ID or a person ID or something like that, which is not going to change between different render cycles. If you've got a static array where you're never going to add or delete items, then the array index would be fine because the index would always point to the same object. But as soon as you start adding things to that array or deleting, you can get into some weird behavior. So the child component, the movie component, that actually gets that movie as an input. So here in the render you see we get the movie from the props. So the syntax with the curly braces is ECMAScript 2015 style syntax, where we're basically saying get the movies objects from the props and name it movies. So const movies is this.props.movies would be the equivalent ECMAScript 5. And then we can kind of define what we want. So in this case we've got a component for rendering movies. It really should be called with a movie prop. If not, it can't really do its job. So we can define required prop types. You can define both required and non-required, but it's especially useful with required ones, because if it's not passed, again, you'll get an error in the console window saying, well, you should really pass this object onto, or some value, it doesn't have to be an object, but some value onto a component as a prop. So in this case, it's specified as an object, which is kind of like any object. You can define a specific shape there, or you can say, well, it should have a name and a title, or it should be a number, or it should be another React component. You can kind of be very specific about this. Quite often, I'm quite pragmatic, saying, well, I just need some object there, and I'm not going to worry about the shape, because then I'll get other errors, and those could happen at runtime when you're not going to see the warnings anyway. But it's useful to add. So that's how you start adding props and inputs to components. Which is nice. Now we can have inputs we pass on to components, but it's still kind of, well, inputs or props are supposed to be immutable. You're not supposed to change those. So if we can't change them, we're still going to render the same thing every time. So we need something where we can make changes. And that construct in React is called state. So each component, at least each component created with a class or React.createClass can have state. If you create a simple functional component, you can't have state. You can have properties, but no state. So state is always internal to component. It has its own state. It can pass that state onto another component. It's a property there. That's perfectly fine. But the only thing which should ever change it is this component itself, which is very important to the rendering mechanism of React. Changes you do by writing a component.setState. So you change the state by setting a new state or a new part of the state, which is a trigger to React, okay, something changed in this application, go and re-render everything from this part in the tree. So basically it says, well, we've got a bunch of components, this one is at set state, so everything underneath there, nested underneath there, could potentially have changed, and it will start re-rendering it. So how does a stateful component look like? Well, it's still just a component, but now we have a constructor. In this case, the constructor adds a state property. It's there always, but by default, the value will just be undefined. And we give it one or more values. The state is always an object, and it has any number of items in there you want to. In this case, I'm just adding a movies, and I'm setting the initial value to null, but that could have been an array or an object or whatever you want to. But in this case, we're going to load some Ajax data, so setting it to null, indicating that it's not been loaded, is kind of appropriate. Then we're going to use component lifecycle events. So there are a whole bunch. Component did mount, component will mount, component will receive props, component will unmount. If you're going to do Ajax requests, the component did mount is the best one to use. Why did mount? Why not in the constructor or in the component will mount, which happens a bit before the did mount? Well, this Ajax request is not going to work when you're doing server-side rendering. Like on the server, where does that go? You might have to get your state from somewhere else, but doing an Ajax request, especially with a relative URL, is not going to work. And even if you did a full URL, so it could actually go somewhere, by the time that Ajax request is done, your server has already returned the markup to the client, and the resulting response is not going to do you any good. So the component did mount will fire on the client, not on the server, making it the perfect place for these Ajax calls. And then we need some kind of way of doing Ajax. Well, with Angular, they're pretty prescriptive. They've got HTTP service. React doesn't have anything like that. React is kind of, well, we're doing UI components. We're not doing a HTTP framework. So use whatever you want. In this case, I've just used the new fetch, which is kind of the new standard, or one of the at least proposed standard, it's not a standard yet, for doing HTTP request. Kind of like the XML HTTP request object, only it returns a promise, which makes it slightly easier to use. It's also really low level though, so be careful with it. But then when it's completed, I basically call this.setState, and because I'm using fat arrow functions here, this still points to the component. And I'm calling component setState with movies object, which again is ECMAScript 2015 shorthand for movies is movies. There is a question there, or not? Just stretching? Oh, okay. So in this case, that movies state is updated. And React decides, okay, we need to re-render this application with the new state. So inside of the render, we're actually calling into another component, the movie list, and passing that collection of movies. And more likely in a real application here, I would have some check saying, well, if movies, this.state.movies is still null, then we've done the Ajax request, but we haven't got the result yet, so maybe we'll show a little loading indicator. And when the Ajax request finishes, set state is triggered, re-render is triggered, movies is now actually an array, so we don't show the spinner anymore, but we show the movie list. So we might have some logic like that, which we'll actually do on Wednesday in the workshop. So one common differentiator with components is to create container components and presentational components. This is a pattern which Dan Abramov proposed, who is kind of well known. Dan Abramov is the developer who created Redux and very good state principles for React applications. His work was so good that he's since been hired by Facebook and is actually part of the Facebook React team now. And he came up with presentational container and container components, also originally called smart and dumb components. Key. So the basic premise of the pattern is to separate responsibilities. So container components are all about doing state management. They are not concerned with how things are rendered. They're only concerned with maybe doing AJAX calls, doing state management and that kind of things. Presentational components are all about receiving their inputs as props. They don't use states, they just use props. They render things, but they're completely unaware of where things came from, how things were loaded, and whether it's just hard-coded test data or the result of an HTTP request. They really don't care. So they take all their input as props. So container components, like I said, don't. Now, one word of warning about this. People take this very literally. It's a very good design pattern, but you can overdo it. If you're going to split all your state management for your presentation management in every component, you'll end up with a lot of additional components. Dan tweeted a couple of weeks back that in a way he regretted coming up with these terms and this presentation or this design pattern because people read too much into it. Yes, it's a good design pattern if used appropriately, but it's a bad pattern if you just use it like thou shalt not use set state in a component which has a render function which renders markup. In general, avoid that, but not always. In general though, if you're creating a more complex React application, you probably want to avoid using stat-state for global state management. Use Redux, which is the library Dan Abramov created, or use MobX, which is very similar but uses RxJS, so reactive principles. They're both great libraries. Like originally when Flux, the Flux architecture as it's called, came out, there were lots of libraries implementing it. It kind of boiled down to these two, and these are basically the only ones used. The general recommendation here is if your application is more complex, more involved, use Redux. If it's simpler, easier, then use MobX. Personally, I'm more of a Redux fan, but they're both pretty good. So event handling. We've got an application now which can render stuff and it can react to stuff being downloaded from a server with AJAX request, but we still want to be interactive, do stuff when the user does something, so we need to handle events. Now all events triggered by DOM elements are exposed to components, so you can basically set up event handlers there and react to click, key press, mouse move, all of those. It's basically React DOM's job to recognize that if you handle a click event, then it will set up the appropriate listener. So what does that look like? Well, we've still got our component. In this case, we've got a login page, which does some local state management. And we've got an input element here, so the normal HTML input element. And in React, there are basically two ways where you can do input elements. You've got what they call controlled input elements and uncontrolled input elements. This is what they call a controlled input element, and you can see that by the fact that it has a value being rendered to a specific thing. So value is this.state.name. An uncontrolled element would not have a value. It would probably not have an on-change event, but typically it uses something called a ref, where you can actually get a reference to the real DOM element at runtime and extract the value from there. They've both got their uses. In general, the controlled inputs like these are a little bit more powerful, but they're also a bit more code. What makes them more powerful? Well, every time you make a change, you type something in that input. This on name change event fires. And the event arc which is passed contains the target, so the input control, which has a value, which is the actual value in there. So we use that to update the state of this component. Which means that the component is re-rendered, and now we can use that state somewhere else. So in this button we've set the disabled attribute to this.state.name.length is 0. So if there is no username yet, the login button is going to be disabled, and as soon as you start typing in the username, then the button will be enabled and you can click it, and then as soon as you click it, that's on-click event fires, which triggers a login function call. This is the kind of thing you cannot do with an uncontrolled input. An uncontrolled input, you can basically only at some later point get its value and do something with it. You can't really react efficiently to every change. But they are somewhat simpler because you don't have to code up that value, that change handler, etc. So that login is just another event handler for a click. Again, it has an event arcs. The event arcs is not the real DOM event arcs, it's what they call a synthetic event arcs. It basically wraps the real event arc into something which is a bit more standardized. There's still some differences between browsers, so they try to avoid those differences as much as possible. It's also an object which is reused, so you do not want to save this, save a reference to this and use the value e.target.value, for instance, at some later point in time. Extract the values you need from it, save those in a different object, save that, that's perfectly fine. Don't save this object. If you really need to for some reason, there is a function on it where you can basically say, okay, I'm taking ownership of it, React, keep your hands off, don't reuse this object, it will create a new one. But you actually create a bit more memory pressure for React that way, so it's better just to let React do its stuff and only grab the data you need, because you typically don't need everything. Anyway, this being a form submit, we don't want the browser to do its default thing and actually trigger a form submit to a server. So we're going to call prevent default, just like you would in normal JavaScript. And then we use, or we do whatever we want. In this case, you see that there is a call to this.props.login as user, which is a function which is basically passed in from a parent component. So properties being passed in don't have to be just data, they can be functions. And in this case, it's a function we can call, so that function will presumably do something about validation of that username and then setting some kind of state somewhere that the user is actually logged in. In the workshop on Wednesday, we're going to do this login, except it's going to be really simple. We're not going to do any validation. Any username password which is non-empty will be accepted, but we'll preserve that username password in local storage. So even if the user refreshes or closes the browser, restarts, it will still remember the username, which is something which is very appropriate for React applications. Traditionally, those kind of things would be stored in a cookie, so they would go to the server with every request. Well, in a React-style application where everything runs client-side, you really don't need that, so you don't store those things in the cookie. You kind of store them in the browser, and you only send along whatever you need with each request. So there's one little trick which you need to be careful with, which bites people at first. Even though in my event handler I bounce to this.click and this.login, if you just try that, you'll get exceptions, at least most likely you'll get exceptions. It turns out that the this reference won't point to the component as you would expect. So you actually have to make sure it does. So what you typically see is inside the constructor here, you see something like this.function is this.function.bind to this. So we're going to create a new copy of the function bound to the current component instance. So inside of that new function, the this keyword, the this reference, always points to the right component. This is nothing specific to React. It's just the way ECMAScript has worked with this reference and always has, but it's kind of annoying, but you kind of get used to it quite quickly. So with that, I'm at the end of the presentation. We still got like 8 or 9 minutes for questions. So if anyone has any questions,